In the last lesson, we learned that scalars have a magnitude only, and that examples of scalars are distance and speed and time. And we learned that vectors have a magnitude, a how much, and direction. And examples of vectors were displacement and velocity. We also learned that um, graphically, if an object moves from A to B to C to D, following this path, that the distance traveled was just the sum of each part. You know, move this far up to the page, this far to the right, this far back down the page, and that made the total distance. But it didn't give us a direction, it just gave us the total distance traveled. And we could calculate the speed if we knew the time that that trip took. We could calculate the speed with distance divided by time. And we learned that the displacement is the change in position, where the triangle is the Greek letter delta, that means the change, and the x means position. So the displacement is the change in position, and we learned that that was as the crow flies, sort of the straight line from where you began to where you ended, with direction. And so in this case, the object was displaced from point A to point B, so its displacement would be that length, and then this direction, if we knew, as that east, west, north, south, positive x, negative x, we would give it a direction. And that is displacement, the change in position. And it's a vector because we included the direction. And the velocity, unlike the speed, the average velocity, that's what the little line over the V means, the average velocity was the displacement over the time. And that this would be a vector because it would include the direction of that change in position. And we looked at a couple of examples of this in the last lesson. And so what we want to do with this lesson is just briefly take a look at a couple of example problems where we want to find distance, speed, displacement, and average velocity. And so in this first example, if we could imagine a person that begins at point A and follows the path indicated, moves from to point B 10 meters to the north. So this is the coordinate system that gives us the directions of what's going on here. And so we start at point A, we move to B, then to C, and then to D. And this person does it in 30 seconds. So we want to find the distance, speed, displacement, and average velocity. Pause the video, solve for those values, and when you're ready, push play, and we'll work through it together. Okay. Let's find the distance traveled. The distance is just the sum of each part of the trip. So that's 10 meters plus 50 meters plus 10 meters. So that looks to me like 70 meters for the distance traveled. Notice that's a scalar. Doesn't tell us which way, just gives us the how much of 70 meters. Now for the speed. The speed of this trip was the distance over the time. The distance is 70 meters. The time is 30 seconds. And so 70 over 30 is about 2.3 repeating. And the units are meters per second, the metric units for speed or velocity. So the speed was 2.3 meters per second. Okay, now for the displacement. The displacement is the change in position, and this position started at A and was changed by moving in the east direction to the east. It looks like 50 meters. So the displacement is 50 meters to the east. Now for the average velocity. The average velocity is the displacement over the time, and the displacement was 50 meters east, and the time is 30 seconds. So 50 over 30, 1.66667, let's just say 1.7. So there's 50 over 30 is 1.7. The units are meters per second. And the direction is to the east. Meters per second east. Okay, I hope you did well. Let's do one more quick little practice problem. So in this next example, looks like an object moves from A to B to C in 60 seconds. So starts at A, moves to the right to B, and then from B all the way back across to C. Looks like we have some distances between these points here of 20 meters. And again, here is the coordinate system, north, south, east, and west, to give us our directions. Calculate the distance, speed, displacement and velocity, average velocity. Pause the video. When you're ready, push play. Okay, so the distance is the sum of each part of the trip. And if we started at A, we went 20 meters to the right. And then if you look, it's 40 meters to go from B all the way back to C. So that looks like a distance of 20 plus 40, 60 meters. Again, the metric units for distance, the basic metric unit for distance is the meter. Now for the speed, it's distance divided by time, and the distance we know is 60 meters, and the time is 60 seconds. So that is 1 meter per second for the speed of this trip. Now, you think about speed, this is what we would be talking about if we said, hey, I went on vacation and I drove to the beach, and it was 400 miles and it took 8 hours. So I guess my average speed was 400 miles divided by 8 hours, which is what, 50 miles per hour would be your average speed. It doesn't really tell you much, just tells you your average rate of covering that distance. So now the displacement, the change in position, delta x. So let's see what that is. Well, we started at point A and we ended at point C. Let's do it up here. So we started at A and we ended at C, which is 20 meters to the west. So that looks like a displacement of 20 meters west. Now, see the difference between the displacement? It it doesn't even matter that the object moved to the right before it went all the way back to the left. All that matters is where did it start and where did it end. Draw a straight line between those 2 points and let that line point in the direction that it moved of that change in position. So we now know this is 20 meters west. And now for the average velocity, it's the displacement over the time. The displacement was the 20 meters west, and the time is 60 seconds. And 20 divided by 60 is 0.3 repeating. So 0.3 repeating meters per second to the west.